Hi, I'm Michael Rangan. I'm the creator of the M4-Breadstick. It is a long, thin development board that has been designed to reduce the number and the length of jumper wires that are required and are necessary when you want to build a circuit, start doing some prototyping, start doing some experimenting and some learning with development boards. One of my uh, challenges that I face when working with traditional development boards is that they're short and all the I/O pins are bunched up right next to each other. So the first step in using one is to take a jumper wire, move it to an empty space of breadboard so you can begin building your circuits. And I find if you were to use, like, say, all 20 pins of an I/O board or a development board, uh, you have 20 wires coming here, and all of a sudden, even if the circuits underneath and underlying are very simple, they have this artificial layer of complexity, and I think that keeps circuits and development boards and programming and electronics out of classrooms because uh, it's intimidating, I imagine, as a teacher to have 20 or so young children coming to you with their individual rat nests saying like, hey, I don't know what's wrong with my circuit, can you help me? It's no way to look at it's impossible to look top down and instantly know what's going on. But this design solves that. You can look instantly top down and immediately understand what's going on. So let's jump into an example. I'm gonna see, let's throw a button example on here. So I'm going to use an internal pull up on pin 9, and I'm gonna put this bus rail to ground, and when we push the button connected to pin 9, we'll light up RGB LED number 9. And there we go. So how clean and simple is that? One wire, one button, and we have input and output. Let's throw a potentiometer in the mix. Now I'm going to throw this onto pin 20, which is an analog input. Notice I didn't have to add any additional wires. It has 3 volts and ground directly adjacent to it. Let's close, load. So this is a simple bar graph example where the voltage on pin 20 is displayed as the display it's converted and displayed as a bar graph uh, going through 0 through 24. And yeah, I love how simple and clean this is. And we have multiple analog inputs. You can wire up all sorts of them. On these 2 pins at the top, because we have 3 volts and ground right next to each other, it's just incredibly easy to throw an analog input on these 2 pins and just have them there and working. Now let's take another look at those RGB LEDs. Let's see what they're capable of. So this is a simple rainbow cycle, and it's just some demo code for dot stars. These are not official dot star LEDs, but they're compatible with Adafruit's dot star library, and uh, they're fantastic. They have data and clock, so you can really push data over serial to these very, very quickly. And I'm looking forward to doing some persistence of vision with these LEDs in the future. I think it'd be very fun for students if they picked up their breadboard and waved it through the air and used this to write some words or draw a picture. I think it'd be fantastic. Now let's do a slightly more complicated example. Let's go ahead and get it ready. So I'm going to take the potentiometer off of that pin. I'm going to throw power and ground over here. So this bus rail's got power and ground. I'm going to throw this potentiometer right here on A1. Let's put a toggle switch over here on pin 20. And, oh, gotta make sure I get that in the right rows. There we go. And let's get rid of this guy. Let's put him on pin 4. I'll put a switch on pin 5. And let's wire up an I2C display, pins 7 and 8. Okay, let's load the code. And there we have it. So we're currently in rainbow mode. I'll switch that off. When the cycle completes, we'll switch over to the other mode. And now we can see that we're in normal mode because of the toggle switch, and this potentiometer's voltage is being read out onto the display. And if I press D4, which is being pulled high by an internal pull-up, we can see if I press it, it switches to false. And if we flip D20, we go back to rainbow mode. So a lot of things going on in this circuit, but it's all kept incredibly clean and neat. And there's still so much room for many more connections. We could do buttons, switches, sensors. If we're running out of room horizontally, we can put development boards that stand vertically. There's all sorts of prototyping that can be done on this platform, and I'm really excited for its future. Anyways, I'm Michael Rangan. This is the M4-Breadstick, and thank you for your time.